starting on lesson 6, compound interest. So compound interest is this idea that if you have an investment, so you put in $100 into an account, that not only, so say in 1 month you make $1, so you now have $101 in your account, that not only does your initial $100 make interest the next month, but so does your interest. Your $1 will also make interest. So you have 101, which means that maybe next month you'll make $1.10, and then it keeps growing exponentially, and that's why it's related to exponential functions. So we have a formula for compound interest, but really it's just the exponential equation in disguise. So if we remember back, we normally have a or y equals a times b to the power of x. It's basically that, just a little bit more complicated. So each of these represents a different thing. So let's erase this here to find out what a is. So according to what we've learned before, a should be your final amount. And that's exactly what it is. It's your end amount. P is the same as A, so that should be your initial amount. We have a special name for that. We call it the principal amount. I is your interest rate. There we go. So there's a formula that we need to use for that. You take your interest rate as a decimal and then you divide it by your compounding factor. And we'll talk about what compounding factor is in a second, because you're going to need it in two different spots in the formula. And then lastly, n is the number of payment periods. You get that by taking your number of your years, your time, and multiplying it by your compounding factor. So your compounding factor is basically how many times a year you are going to get interest. So maybe it's daily. If it's daily, that means that your compounding period is 365. Maybe it's weekly. If it's weekly, that means your compounding period is 52. Now, the ones that are more common will be these ones down here: the monthly, quarterly, and semi-annually. So make sure you recognize those terms. If it's monthly, that means it's once a month, so your compounding period is 12. If it is quarterly, that means 4 times a year. Semi-annually means twice a year, and then annually means once a year. So let's start our first example. $3,000 is invested at 4% per annum, compounded semi-annually for 5 years. Determine the amount of money she has at the end of 5 years. How much was interest? So I copied the formula, but do know that you will have to memorize it. The more you use it, the better you'll get at it. So A equals P times 1 plus I to the power of N. So let's list what I know. I know that 3,000 is how much I started with. So in this case, that's going to be my P. P, my principal amount, is 3,000. 4% per annum. So my rate is 0.04. So that's 4% as a decimal. It's compounded semi-annually. Semi-annually means twice a year. So my compounding factor is 2. And the time that it's in is 5 years. So now we need to sub it in to find out what A equals. So A equals 3,000 times 1 plus my interest rate divided by my compounding factor to the power of my time times my compounding factor. Okay, so now that we have our formula, it's really important that we're able to type this into our calculator carefully. A couple different things that I will have you notice is that this fraction here needs to be in a separate pair of brackets, and your exponent also needs to be in a separate pair of brackets. Otherwise, it'll take it to the power of 5 and then multiply it by 2. So go ahead, try typing that in, and see if you can get the correct answer. Okay, so I got A equal to $3,656.98. So this is how much money they have in their account at the end of the 5 years. So the question not only says how much does she have, but how much was interest. So your interest is going to be your A minus P. So in this case, 36,056.98 subtract your initial investment. So she earns $656.98 for interest. All right, hopefully you're starting to get the hang of it. Let's try another example. Nora invested $4,000 in a 3-year GIC compounded quarterly at a rate of 2% per annum. Per annum means once per year. Determine the amount of money she has after this time. So once again, I am trying to find A. A is equal to my initial investment of $4,000 times 1 plus my interest rate, 0.02, divided by my compounding period, which in this case is 1 because it's per annum, to the power of my time, times by my compounding period. So in this case, the 1 isn't going to make a big difference. Go ahead and type that into your calculator. And you'll find that she now has $4,244.83 in her account, which means that in those 3 years she made $244.83 in interest. Okay, we have 2 more examples left to do, example 3 and example 4. I want you to pause the video and try these examples on your own first, and then I will post the answers. So go ahead and pause. Okay, here is the answer for example 3. At the end, they would have 3,249.43. And here's the answer for example 4. All right, it's your turn. I want you to try lesson 6 worksheet numbers 1 to 8. Tomorrow we will look at the last few examples, which basically take that formula, but now we're solving for something other than the accumulated amount. So maybe we'll solve for how much was invested originally. Maybe we'll solve for the time it was invested, that kind of thing.